Section 8.4 starts with trigonometry. It takes what we've already done with right triangles and adds a new, completely new concept called trigonometry. So, important definitions. Trigonometry is the study of angles and triangles, and how the ratios of the sides of those triangles affect the angles. So, for any angle, and this is the Greek letter theta, that letter is in a right triangle as shown. We have three sides. We know the hypotenuse already, and then we just had two legs, but we're going to be more specific. We're going to call one of them adjacent, one of them opposite. The opposite side is across from the shape. It's across from the angle. It's the one that corresponds when we did 30, 60, 90 triangles. The leg across from the 30-degree angle would have been the opposite side in this case. And then the adjacent side, adjacent means next to or touching. So the angle, or the side that forms that angle with the hypotenuse, is called the adjacent side. The right angle can never be theta. It's always one of these two angles next to the right angle. So we have three ratios. You've probably seen these in your calculator. These three: sine, cosine, and tangent. Sine is actually spelled out S-I-N-E, cosine and tangent. That's how they are written out. So, sine is the ratio of the opposite side and the hypotenuse. So whenever you want to find the sine of this angle, you take the opposite and divide by the hypotenuse. Cosine is the adjacent side divided by the hypotenuse. And tangent is the opposite side divided by the adjacent side. So the ratio of these different sides make up these trig functions. There's three other trig functions that are inverses of these. We won't be talking about those during this chapter at all. So, example 1, find BC. So first off, I just need to find the other side, because you can't do this unless if you have all three sides. Let's call that x. 5 squared plus x squared equals 7 squared. X squared is, and this is 25, this is 49, so I'm going to take 49 and subtract 25. I get 24. So x is the square root of 24. Don't forget to make that factor tree. You got a pair of 2's, and you have a 2 and a 3 left uncircled, so 2 square root of 6. So that side is 2 square root of 6. Now, part B, find the tangent of B. Tangent is opposite over adjacent. The opposite side from B is 5. The adjacent side is 2 square root of 6. We would be done here except for square root of 6 cannot be in the denominator. Five square root of 6 over square root of 6 times square root of 6 is 6 times 2, 12. Now I need to find the cosine of A. A is up here. That's my new theta for the second part. Cosine is adjacent over hypotenuse. Adjacent is 5. Hypotenuse is 7. Find the sine of n if the tangent of n is 5/12. So before I do this, what I want to look at is a way to write sine, cosine, and tangent. So sine, I'll use S, C for cosine, T for tangent. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. You're going to see me write, let me get rid of that. You're going to see me write it like this throughout. This helps me just remember sine is opposite and hypotenuse, cosine is adjacent and hypotenuse, tangent is opposite and adjacent. If you read this word, if you make it into a word and read it, it's SOHCAHTOA. So SOHCAHTOA, if you hear that, we want to write this out and use this as our reference. So find sine of n if tangent of n is 5/12. So SOHCAHTOA I need to find sine if I know the tangent. So let me get a triangle here. We know that the tangent of n, let's call this n, is 5/12. So tangent is opposite over adjacent, means 5 is the opposite, the adjacent is 12. I need to find sine of n. So before I find sine of n, because I need the hypotenuse, I need to find that hypotenuse. If you remember your triples from the third video in 8.2, 5, 12, and 13. So sine of n is opposite 5 over the hypotenuse, just like it says up here in SOHCAHTOA, 5/13. So now I need to go backwards and I need to find which angle has a ratio of 15/8 and which one has a ratio of 8/17. The third side here, 8, 15, 17, because that's a triple. So when I look at SOHCAHTOA, tangent is opposite over adjacent. So where is 15 the opposite side? Well, you got to go across the shape. So that's the tangent of A. The tangent of B, if I had to find that, tangent of B would be the opposite, 8/15. 8/17 is which one for cosine, A or B? So cosine is adjacent over hypotenuse. So where is 8 my adjacent side? 8 is touching this angle. So that's the cosine of A. Alright, let's find the exact values of these. If you look, we can only find exact values when we have 30, 60, 90 triangles or 45, 45, 90 triangles. So let's get both of those drawn. The reason we can do this, we have 1 over leg, root 3 over leg, 2 over hypotenuse, 1 over leg, 1 over leg, and square root of 2 over hypotenuse from 8.3. So we're going to use these two triangles to help us figure out sine, cosine, and tangent. So the sine of 60 is, let's write SOHCAHTOA one more time, and sine is opposite, square root of 3 is across the shape, over the hypotenuse, which is 2. Cosine of 60. Cosine is adjacent. The side touching 60 is 1. The hypotenuse is 2. And tangent of 45. Tangent of 45, well, it doesn't matter which angle we pick here because both of these are 45. We'll get the same regardless. So tangent of this, let's do opposite. Opposite is 1. Adjacent is 1. Tangent of 45 is just 1. Here's a problem that shows up on the ACT. The sine of A is 3/7. So here's A. We know that the sine of that is 3/7. And I want to find AB, which is my hypotenuse. Oops, went away. So if I know that the sine is 3/7, I also know that it's opposite over hypotenuse. These two are equal because they both represent the sine of A. So take 7 times 14. When you cross multiply, you get x equals 98. 3x equals 98. Then you're going to divide by 3, and we get 98/3. There is no third side over here, so you can't do Pythagorean theorem just to find AB. You have to use sine.